Hi everyone, my name is Arjun. I'm one of the founders of Connext. This talk is about building cross-chain applications. But generally speaking, when you see the word chain in this talk, you can actually replace it with domain. Basically what I mean is any kind of execution environment on top of which you could build applications. We just say chain because it has better SEO. So let's start by talking about the multi-chain world that we live in today. There's a really interesting kind of user experience hurdle that people are starting to bump into that's only going to grow with time as we move towards like the massive proliferation of zk sync L3 rollups, Polygon supernets, other kinds of chains and execution environments that fragment the user experience. This is the Aave UI. I hope everyone here has familiarity with like Aave's user flow, but generally speaking, Aave has, at least when it was on Ethereum by itself, has this very nice user experience where you basically just deposit funds into the system and then borrow against them. There's really not much else beyond that. It's just an interface that's directly connected to smart contracts underneath the hood. Now the problem that we've started to run into is that Aave has now been deployed to many different ecosystems. And so now you have this like really kind of weird experience where if you're a user that wants to use Aave on Ethereum, you need to go and actually use the Ethereum version of the Aave application. And if you're a user that has a position on Aave on Ethereum and you want to switch that position to another chain, you have to do something even more ridiculous, which is actually leave the Aave application. So pull your funds out of Aave, leave the Aave application, bridge to another chain, and then deposit funds back into Aave. This is nonsense to most users. I mean, to everybody in this room, you kind of understand the core concept of why this needs to happen, but for any new user that's entering into the space, this is just a ridiculous experience. And it's because fundamentally this is not really how we use applications on the web today. When you go and do a Google search for cat videos, you're not actually you're not really viscerally aware of the fact that Google is doing a search across like many sharded databases to be able to pull up the data that you need to actually access those videos. You're just interacting with the application interface. And in the same kind of vein, we want Aave to behave in a way where you're just interacting with the Aave application, and behind the scenes, you kind of take care of this this really weird cross-chain experience of needing to interact with multiple chains. So in other words, there needs to be a bigger separation between the underlying chain, the underlying settlement layers, or eventually even execution layers, rollups that you're building on top of, and then the application interface that the user is interacting with. And in that middleware, there needs to be a mechanism where users' transactions are actually routed to the right place, where their liquidity is going to the right place in the first place. So in that way, a user doesn't necessarily need to know or care what chain they're on. In the same way that you, as a user, don't really need to think consciously about the complex, decentralized, distributed infrastructure that exists behind Google. And I've said the C word a lot in this talk so far, and that makes people really nervous because cross-chain is a really scary topic. Bridges are extremely terrifying. And it's no secret that the reputation of bridges right now is pretty much at the worst that it's ever been, especially after the $500 million Binance bridge hack that just happened. So how do you kind of reconcile these things, right? How do we move past the fact that I think this was actually before the Binance hacks, I think it's about $2.5 billion of value has been lost in bridge hacks over the course of the last like year and a half. How do we operate in an environment where this is also happening? And how do we actually work towards secure bridging, secure communication across blockchains? And before we even get to that point, do we even really need bridges to begin with? Now, I think these are all really important questions that people are asking themselves today. One of the unfortunate answers is that we do kind of need bridges. So a lot of people think about bridges as mechanisms to communicate between different layer 1 systems, but the same core concepts apply regardless of whether or not you're doing communication between execution environments, from an execution environment to a DA layer, so a rollup bridge between DA layers, or from a DA layer to a settlement layer. These are all things that are going to exist. They have to exist because, as we've found out over the course of the last 5 years, there is no way to scale blockchains in a monolithic way. You need to have communication between blockchain layers. And once you acknowledge that that's the case, you kind of realize it's all bridges. In fact, this whole space, the study of layer 2s to begin with, really is just the study of bridges. So how can we actually build safer bridges? I could give a talk on this for like hours. It's it's such a challenging topic, and it's something that's really, we and other bridge projects are actually just starting to figure out right now. But at a high level, I think some of the key things that we've realized are, the first thing is modularize the stack. So Alex in the last panel was talking about how you actually secure the ZK VM in a way where like when you have these very complex cryptographic primitives, you don't necessarily introduce a lot of new risk to building applications. And you do that by basically having like isolated layers, right? You modularize these systems, you isolate the security of those systems, you basically test each system in isolation, and you make sure that each system actually works perfectly before you build on top of it. And the same kind of ideas can be applied to bridges. And there's a lot of really interesting parallels between bridges and blockchains here that I think people will start thinking about as I keep going through this talk. But you can isolate the different pieces of the bridging stack to separate out transport, for instance, which is how do you get data from one chain to another, from verification, which is how do you actually check to see whether that data is correct to begin with. And when you separate out all of those pieces, you can do something really interesting, which is minimize the need for external dependencies. And basically what that means is reduce the need to go and interact with infrastructure that isn't already available and battle tested within a given ecosystem, right? So for instance, roll-up bridges. The ZK Sync bridge is going to be the most effective way to get into and out of ZK Sync. It's also going to be the most battle-tested mechanism. So why introduce another external dependency? Why introduce another system for communicating across chains when you can actually use the ZK Sync bridge for the things that it's good at already? In addition to that, there's a couple of other newer techniques that we are now starting to research and that have kind of been talked about a little bit with the creation of things like optimistic bridges. One of them is using delays and off-chain watchers. So basically having fraud proofs, have a mechanism where an off-chain set of actors can halt the system if they notice something is going wrong. And this needs to work in conjunction with rate limits. Basically, remove the ability for people to be able to withdraw a very, very sizable amount of funds from a bridge or from any kind of ecosystem, really, in this space, in just a single transaction. The combination of those two things allows, for instance, a world where you could have a bridge that has $100 million secured within it, but where you were only able to withdraw $10 million out of it within a 10, 15-minute time period. And so if a vulnerability does occur, the total amount of damage, total amount of collateral damage that ends up happening as a result of that vulnerability is mitigated, because you can have $10 million lost within that time period, but then the system is halted. I'm going to switch over to Connext now and talking about a little bit about how Connext works. Connext builds on a lot of these core principles. We are trying to find a way to do safe bridging and safe communication between blockchains. And it's a new enough space, it's a complex enough space that a lot of the core ideas around like how we should be thinking about it are only just starting to be discovered. One of the things that Connext leans very deeply into is modularization. So basically separating out all of the different pieces associated with the bridging stack so that Connext can rely on existing systems as much as possible. So for instance, Connext provides a bridge execution layer, which basically is a mechanism by which you can communicate, like developers can pass in data into a bridge to be able to communicate between chains and then execute a transaction on the destination chain. But that execution layer plugs into whatever the best underlying systems are for messaging in a given ecosystem. So for instance, in the ETH ecosystem, Connext plugs into rollups. In the Cosmos ecosystem, Connext will plug into IBC. And it makes sense to do that because IBC is the best mechanism for communicating within the Cosmos ecosystem. Rollup bridges are the best mechanism for communicating between rollups. And then in the event that there isn't already a very powerful mechanism available, and also in the event that there's technology that isn't battle tested, Connext also implements the kind of fraud proof mechanism that I talked about in the last slide. The combination of all of these things is that we hope that Connext can create an experience for communicating across chains that actually legitimately remains as safe as the underlying chains, or at least as the underlying infrastructure that is securing a given rollup or other ecosystem. Connext lets you build cross-chain applications. And this is, I think, the really, really big change, that is kind of coming as a result of moving to this like fragmented multi-domain environment that we're working with. Alex touched on this in the panel when he was talking about communicating between layer 3 rollups on top of ZK Sync, where you can have like seamless composability, seamless and trust minimized communication between them, but that communication needs to be asynchronous. Connext is the project that introduces this asynchrony primitive. We create this really, really simple function called xcall. This is actually the entire interface of Connext is just this function. This function, xcall, is designed to map to the lower level Solidity call function, which is basically the lowest level function that allows you to execute a transaction or basically call a function on another contract from a contract on the same chain. This is the basis of composability on Ethereum today. And xcall does the exact same thing, but in an asynchronous environment. What do we mean by asynchrony? A good way to think about asynchrony is to think about how you build web applications today. So when you are building on top of the internet today, you basically, any application that you build is interacting with a backbone of servers and other kind of data sources that exist all over the world. You're not actually building everything in like a singular execution environment. You're interacting with resources that exist everywhere on the web. And you do this using, I guess JavaScript really is the most popular mechanism for doing this at the moment, but you use this basically using, using something called callbacks and asynchronous communication, where you fire off a request to go get some data from somewhere else on the web, continue executing your program, and then later on receive that data and do something with it. xcall introduces the same kind of core concept to Solidity. So instead of calling a contract on the same chain, you xcall a contract on a different chain. You basically pass whatever function params you want to this other environment. That environment can, the target chain, the target contract on the destination chain can then execute some function associated with the data that you've passed it. And then later on, it can return that data back to the source contract, kind of like a callback. And in fact, you can do even more than this. You can actually even have nested xcalls, where you can have the target contract on a destination chain, then go on to call other contracts that live on other chains, basically creating a world where you can have a program that runs on a single blockchain that then interacts with every chain all at once. And how does this look from a developer perspective or from a user experience perspective? Well, the goal is to try to minimize the changes associated with moving to this asynchronous world as much as possible. So of course, there are some challenges associated with like, okay, I'm doing a transaction and the whole transaction is not just going to execute inside of a single block. It's now going to execute over many, many blocks because it's interacting with many chains. But the experience of actually initiating that transaction can still be the same. So for instance, in Connext, you pay gas on the origin chain and as part of your transaction in native assets on the origin chain. And then you bump gas if there's not enough gas available to complete your transaction in the exact same way that you do with making any kind of transaction on Ethereum today. In practice, it's actually quite simple. And this is the goal. Is we've sort of been very, very neurotic about trying to minimize the additional changes that developers need to make to be able to interact with this infrastructure as much as possible. The goal is if you can eventually get to the point where xcalls are basically a low enough level primitive that they work exactly the same way as calls, developers don't really need to change their patterns. Users don't really need to change how they think about interacting with applications. And all of the supplementary infrastructure in this space still kind of functions. But we've been able to make the transition from this synchronous world where everything lives on a single chain, this monolithic world that we live in today, to this more interesting asynchronous world. To kind of give an idea of what that looks like, I'll talk through some of the use cases that people are building on top of Connext today. And I hope that this can give people a better understanding of the power of cross-chain applications. And even beyond this, I'll kind of go into some of the use cases that I'm personally very excited about, which I think really will open up this space in a very interesting way over the course of the next few years. One of the ones that I think is very near and dear to my heart is Superfluid. We use Superfluid at Connext pretty much every day because we pay all of our ecosystem contributors in a recurring way. And one of the biggest problems that we run into is that those contributors are actually contributing across multiple different chains. And our treasury is actually across multiple different chains. And so there's this really kind of annoying user experience hurdle of us having to manage superfluid streams on multiple chains all at once, and manage accounts on multiple chains all at once. Superfluid is built in integration into Connext, where you can actually just have cross-chain money streaming to begin with. So start a stream on any chain, terminate that stream on any other chain, or be able to start streams from a wallet on any chain to multiple chains simultaneously. KeeperDAO is also building something really interesting where they're taking Uni v3 TWAP oracles across chains. So TWAP oracles are just such a core dependency for any protocol that is trying to minimize like off-chain oracle dependencies. But of course, if you have a trusted bridge mechanism that is taking TWAPs across chains, you've now just created the exact same oracle dependency that you tried to avoid. And so through Connext, through being able to push a lot of this like Oracle data through like roll-up bridges and other kinds of ecosystems, you can have access to TWAPs that have the same base level security as they would on Ethereum. Of course, there is a bit of a delay to accessing that data, but in general, it's still a massive stepwise improvement against using like an off-chain Oracle data source everywhere. FujiDAO is actually solving the problem that I talked about at the start of this talk. They are building basically middleware that exists on top of lending protocols, on top of Aave, Compound, and other kind of longer tail lending protocols on other chains, where as a user, you can just lend on one chain and borrow on another. You don't have to think consciously about which ecosystem you're building on top of or which ecosystem you're deploying liquidity on top of. NFT Hashi is building a cross-chain NFT ecosystem. They're a bridge, protocol, and marketplace. Gnosis Zodiac. So Zodiac is a project building within the Gnosis ecosystem that is creating DAO tooling. And one of the key aspects of DAO tooling that they're very interested in is cross-chain DAO governance. So how do you, for example, if you're Uniswap that is running, that has their DAO operating on top of Optimism, how do you update like low-level Uniswap protocol params around fees and fee collection run on Polygon? It's a really, really interesting question, right? How do DAOs operate in this multi-chain environment? Well, Zodiac solves that. It's a simple like safe plugin that any DAO can integrate and just be able to interact with contracts on any chain all at once. One other use case that I kind of like jump ahead to here, because I think that there's I think this really like showcases the like power of moving to this cross-chain world is being able to bridge between EVM compatible or even non-EVM compatible blockchain-like environments to things that are not even chains. And one of the really, really cool use cases here is being able to build connectors into systems like Arweave or Filecoin. So imagine if you could actually have contract-owned storage on top of Ethereum or on top of a rollup. There's something really interesting there where like right now you have this like separation that exists between the application logic that exists in a smart contract and then like the storage that you do separately using decentralized systems like Filecoin and Arweave. But if you have contract-owned storage, you can build like significantly more sophisticated applications. For example, you could build like a uncensorable GIS data API that exists as a contract on top of Arbitrum that users pay, and that contract goes and retrieves GIS data that can never actually be taken down from Arweave. That is a full stack API application that you would have, like a SaaS application that you would have built in Web 2 that now exists in a purely decentralized context. Another really interesting one is you could, for instance, you could create a neural net where the neural net's weights exist on top of Optimism. That neural net communicates with data that is stored, that executes over data that is stored on Filecoin. So you basically feed it data sets from Filecoin, and it executes that data using Golem network or Render. That actually lets you create legitimately like public infrastructure artificial general intelligence, right? It's OpenAI if OpenAI was actually done correctly. There's a lot of really, really interesting things here that get like an interesting world that gets created as a result of moving to this cross-chain environment that starts to get to the kind of like Ethereum world computer thing that I think that actually like drew a lot of people to this space in the first place. Anyway, on that note, I think that's basically I wanted to kind of like give a brief overview into how people are thinking about bridges and cross-chain communication and some of the really exciting things that are happening there. If you're interested in learning about more about what we're doing, definitely check us out. We are in the process of like completing a network upgrade that allows us to move towards this kind of generalized communication, which should be live in the next couple of weeks.